Hello, my name is Jared Gustafson. I'm going to share today with you something that I really enjoy about Desmos Classroom. In the custom activities, I think that so many intelligent people are making so many just phenomenal activities, and I love that everybody can share and kind of grab from things and like edit things and look at how people are doing things and try to make it fit your own style. And I'm going to share something today that I really enjoyed making that was for geometry class, kind of introducing students to proofs. And as you can see by what's up on the screen right now, I'm trying to get them this idea that, like, if you think about the game Uno, you kind of get this, like, if this, then that kind of structure, and it helps them kind of introduce things to proofs. And I think Desmos has made this really great in a way that, like, the kids can interact with it. You don't have to spend a bunch of money on cards just to spend the 5 minutes talking about how Uno can kind of help them build this skill for proofs. And inside the Desmos activity builder, I just think there's so many great things to do, but kind of just like starting like in the graphing window, there's so many different ways you can do things. So one thing that I found to be great is that you can put in points, you put in kind of variables in, give them some sliders. I don't know which one. There it is. I grabbed the right one. And this is just a point that we can drag somewhere across our screen. And of course, I show the students, like, if you're thinking about the Uno game, you can play a yellow 6 on top of a yellow 9 because they're the same color, that kind of thing. But you can put in points, you can give them labels. And then, as you can see, of course, with the cards as well, I just have to find one of my little stashes here, that you can insert pictures. And I think that Desmos is so great in how kind of intuitive you want it to be. So like when you want to put a picture in your graphing area, as you can see, I downloaded a picture of a snake right here. You simply have to take your file and drop it in. And then to give it size, to give it something you can move, you can put some things in here. So if you recall from when I had this point here, I just gave it a variable of A1 and A2. If I wanted to call some variables, some things, and give them some sliders, you'd be able to move this picture around. You can change its size quite easily right here. You can change, seeing how opaque it is, kind of see-through, kind of just have a snake there in the background, for whatever reason. So I just think it's so straightforward to kind of like have this blank canvas to kind of just put something on that kind of fits what you're trying to do with the kids. Inside of this activity, I'm going to share one more thing. Inside of these graphing windows, something that I don't remember when I learned this myself, but I think is just really cool. So you'll see here on this slide where we're actually talking about like doing some very basic introductory proofs for class. I just put kind of a T-chart in the background as an image. So I just, typed that up somewhere, took a snip of it and put it in here. And then I was able, through just investigating other people making things, figure out a way for the kids so that when they're doing this on their own, they don't need me to walk around and check to see whether or not they're getting things right. So if I put everything in the approximate right spots for the proof, you'll see something pop up and it tells you immediately that you got something right. I think Desmos is full of things that give students just feedback immediately. And this is a slightly more complicated way to do it, so I'm going to show you right here how I was able to get this to work. So for each of these points, I was able to, let's see, what do I want to click on here? I was able to label each of my points with my variables. You'll see, I think, yep, there's my A1 and A2, and you'll see that they have coordinates attached to them based upon some sliders. And if I scroll down enough, you will see that I am defining some other variables. So I called capital A11. I am looking for when. So this is basically kind of like a true-false gate. where I'm looking for my A1, which is my x coordinate of this point. Oops, clicked on the wrong thing. Let's go back down there. I apologize. This right here is looking for when A1 is between x values of -10 and 0. I have, of course, hidden the grid for your Cartesian plane. You can, of course, not have that hidden when you're doing these kinds of things. But you'll see when I grab the point and I move it outside of its window, kind of your true-false window, 1 for true, it works, 0 for not, the moment it's in its correct x placement, which happens to be kind of close to the edges of this proof right here, I get a little too far to the right, and you'll see that it turns 0 here. Now, I was able to go through and, maybe a little monotonously, turn on some variables for each one of these coordinates. You'll see A22 right here wants my y coordinate of this point that I've been playing with to be between -2 and 0. So its y value needs to be between -2 and 0. So you'll see when this point is a little bit higher than maybe you would handwrite it, it's still going to have something pop up here because I'm not being as picky about my window, but I picked some numbers that were easy to work with and didn't take a whole lot of typing because there's a whole lot of just copy and pasting of this stuff. So I went through, defined some variables, and then you see this big ol' line right here where I have this variable s that I defined where I'm taking all of these defined variables, my kind of like truth variables if I were to call them, and I am looking to see when you multiply them what they get. Because here's the thing. If any one of these happens to be 0, if any one of these happens to be false, this turns this new variable s to a 0, so it turns it off. And as you might guess, this s variable is connected to something that is in charge of making this picture that I added in show up when it's ready. So kind of going through defining some truth-false windows for all 6 of these points, defining like B11, B22, and having another R, kind of like that S, I defined one more variable, which is my S times my R. So when all of my coordinates, X and Y, for all 6 of these points are in the true position, they're in the place where they need to be, everything's a 1, nothing's 0, so when you multiply them all together, you get 1. So right here, here's my nice job picture that I have in. This is the coolest thing right here, is in my width, I have the width defined to be 10 only if, so in these curly brackets, I'm having my variable z, which controls the true-false nature of this picture. When z equals 1, when everything is in the right spot, this picture shows up, which I think is just so cool. There's so many small things you can do, even inside just simply the graphing window that Desmos allows you to do. It's phenomenal. It kind of opens up so many things. Thank you for your time, and have a wonderful day.